Hi Algebra 1 students, this is Miss Penn and I'm doing some video notes for you guys over the weekend on lesson 18 on graphing cubic, square root, and cubed root functions. So I'm going to kind of run through the classwork here today, and then in class you will be responsible for the problem set. So to start, we're going to just take a quick look at evaluating each of these functions for a specific x value. The idea just to make sure we understand what each function is doing. So when it says evaluate x squared when x equals 7, that means we're plugging in 7 for the x. 7 squared, that means 7 times 7, and I get 49. For the next one, I do the square root of 81. So I'm thinking, what number squared is 81? I know that would be 9. And when we're doing this, when we do a square root, like technically you can say, well, it would be plus or minus 9, right? But for when we're just evaluating this function, we're always going to choose the positive value of the root because we don't want there to be a positive, we don't want there to be two y values for one x value. So we will always choose the positive version of the root when we deal with the square root function, okay? For the next one, we have 5 to the third power, so that's 5 times 5 times 5. Well, I know 5 times 5 is 25, times another 5 would be 125. And then for the last one, you may not have seen this before, but this is the cubed root of x. So it means like some number raised to the third power is equal to 27. So I need to try to think about what to the third power is 27. Well, I know like 9 times 3 is 27, and I also know 9 is 3 times 3. So then my thought would be that 3 to the third power is 27. So that means that the cubed root of 27 is equal to 3. So like you could check that on the calculator by doing 3 to the third. And you see we get 27. Now the other thing you can do is if you want to like evaluate this in the calculator, you would have to write it as 27, and then you'd use that little caret button to say raised to the 1/3 power. Okay, so like it would end up looking like 27 to the 1/3 power. So if we put that in the calculator, we should get back 3. So 27 raised to the 1 divided by 3 power. So the idea is these fractional exponents end up being equal to roots. So if I have the cubed root, I'm raising it to the 1/3 power. And I do get 3 back. So we can verify that that is the correct answer. Okay, so moving right along, we're going to take a look at exploratory challenge number 1. So it says using your graphing calculator to create a data table for the functions y equals x squared and y equals the square root of x. For a variety of x values, use negative and positive numbers and round your answer to the nearest hundredth. So if I'm using my calculator, well, the first thing I'm going to do is put the functions into y equals. So I'm going to go over here to the y equals button. So I'm going to put in a bunch of numbers here. I'm going to delete them. Okay. So in the first, for y1, I'm going to put my first function, which is x squared. So I'm typing in x, that's the x button, raised to the caret 2 power. And for the next one, I'm doing the square root of x. So I would do second x squared of x. And then to see the table, I'm going to push the second button and then the graph button. And it takes me to my table of values. So it says we should be doing some positive and some negative. So the idea is that the x values are in this first column. Y1 is my x squared function values, and Y2 is my y squared function values. Now notice that we're seeing that for certain values of x, in the square root of x, we're getting an error message. Okay? So the idea is, why are we getting an error message there? Well, we'll think about that in a moment. But for now, let's just fill in the table. So I'm going to do from -3 to, or maybe I have 1, 2, 3, I have 5 spots. I'm going to do -2 to +2. Okay, and then using my calculator, I know that x squared at negative 2 is 4, negative 1 is 1, 0 is 0, 1 is 1, and 2 is 4. So I get, and again, I'm just like looking at the calculator and pulling those values. So similar idea, but for the negatives here, I'm not going to have anything. But then at 0, the square root of 0 is 0, the square root of 1 is 1, and the square root of 2 is approximately 1.414. Okay, now let's think, well, what's going on here? Why don't we get values there? Well, what happens if I do the square root of a negative number? Well, let's say it's square root of negative 2. That means what number? Some number to the second power is equal to negative 2. If you think about it, no number to the second power, meaning times itself, could ever equal a negative number. Because if I'm multiplying a number by itself, that means it's either positive times a positive or negative times a negative. But a negative times a negative is positive. So there's no way to square something and have it turn out to be negative. Okay? So the idea there is you will always get then an undefined value or an error message in your calculator when you try to square root a negative number. Okay? So the big takeaway here would just be that we can't square root a negative number. And so the conclusion is also that our domain here for y equals the square root of x would be restricted to values of x that are 0 or greater, right? So x would have to be greater than or equal to 0 because we know it can't be less than 0. Now, what is my domain for x squared? Well, here, I don't have any problem plugging in negatives. So my domain for x squared is just all real numbers. Okay, so now we're going to move on to the next page. And on the next page, it's asking you to create the graphs of x squared and square root of x on the same axes. So I'm just going to think, I have to think about like what do I need to count up to on my x and y axis? Well, all of my values were from negative 2 to 2 on x, and then everything here is positive, is greater than 0, right? And I only need to get up to 4 on my y axis. So I shouldn't have any problem there. So I'm just going to kind of center, drawing my x-axis. And I'm going to say like every two squares is 1 unit, just because I have enough space to spread it out. So now I'm going to graph x squared in green. So the first point I'm plotting for my table is negative 2, 4. The next point I'm plotting is negative 1, 1, then 0, 0, 1, 1, and 2, 2. Sorry, 2, 4. Okay, now I'm going to sketch my curve. So that would be the graph of y equals x squared. Do something similar for the square root of x. So I'm going to have a point at 0, 0 still. Then at 1, I have a point at 1. So those 2 points kind of overlap in both. And then at 2, I have 1.41. So it's a little bit less than half. 1.5. Okay? Now it's kind of hard to tell like exactly what's going on here. So I might want to just grab a couple more values of y for the square root function. So then after 1.14, I have 3, 1.7. So let me plot that 3, 1.7. It's about there. And then the next one is 4, 2, because the square root of 4 is 2. Okay, so now we're kind of getting a better sense of what this looks like. Something like that. Okay, so now I want us to think about our range for each function, because we already thought about the domain. We said for the x squared, the domain was all real numbers, right? You can plug in any x value. But the range for y equals square root of x was only x greater than or equal to 0, and we see that we don't have any values over here on the negative x side. Okay, so what about our range? Well, the range for y equals x squared, if you take a look, the range is your set of all the y values. We see we have nothing below the x-axis. There are no negative y values. So our range here is going to be x is greater than, or sorry, y is greater than or equal to 0. And what about for the square root of x? Well, the square root of x, it also has all positive numbers, right? All positive y values. So we're also going to, or 0. We're going to say y is greater than or equal to 0 for that as well. Now, something I want you to notice here is that we see that we have, like, if you just look at this right-hand side of our parabola and you ignore the left hand, we get this kind of nice design between the green curve and the pink curve. And they're actually symmetrical across the line y equals x. So we have this line of symmetry of y equals x. So that means like that's the line that starts at 0, 0 and has a slope of 1. I'm going to kind of draw it in as a dashed line. Okay, but if you can kind of imagine that the graph of x squared got reflected over this line y equals x and turned into the graph of the square root of x. And that makes sense because in a way the square root function is undoing the squaring function, right? So the x and y values are going to be switched there. So that's the idea behind the relationship that we're seeing graphically, is that there's this line of symmetry where that if you reflect x squared over this line of symmetry, we get the graph of the square root of x. Okay, so now we're going to move on to the next exploratory challenge, and I'm actually only going to start this one for you. I'm not going to finish, so you're going to finish in class. But the idea here is we're going to, again, it gives you the x values now, but we're going to do something similar. So I'm plugging in these x values into x to the third power. I could also rely on my calculator to get those values, but I think I can do it in my head. So if I'm plugging in -8 to the third power, that's 8 times 8, which is 64, times another 8. Might have to do that on my calculator. So we have 8 raised to the third power. We get 512. Now if I'm doing the cubed root of -8, oh, I'm sorry, so this should be -512 because I'm doing -8 times -8, positive 64, times another negative will end up being negative here. Okay? So then here when I'm doing the cubed root of -8, I'm thinking something to the third power is -8. Well, the answer there would be -2. Because -2 times -2 is 4, and then 4 times another -2 would give me my -8. Okay, so now for the next one I'm doing -2 cubed, and again, actually I know that's going to be -8, I just did that. Now to do the cubed root of -2, that's not one I can do in my head. So for that I am going to rely on my calculator. So I'm going to go back and switch out for x squared, I'm going to put x to the third. And for the square root of x, I'm going to write x raised to the 1/3 power, which is equivalent to the cubed root. Okay? So then if I do second table, I see that when x is -2, the y value for the cubed root is -1.26. At -1, I have -1 here, And I also have -1 here because the cubed root of -1 means -1 to what power is -1? Well, -1 times itself is +1 times another -1 would give me -1 back. I can confirm that by looking at the table here. Okay, so the next one is 0 for both. That 1 is going to be 1 to the third power is 1, and the cubed root of 1 is also 1. 2 to the third power is 8, and then the cubed root of 2, I imagine it's going to be the positive of that. And we can verify that by looking at the calculator. And it's 1.2599. That's the same as the, just rounded slightly differently. So 1.26, and then 8, I'm going to get the positive 8 to the third is positive 512. And then the cubed root of positive 8 is positive 2. Okay, so notice for this, because now we have an odd root here, we are able to plug in negative numbers, right? So the domain here for both of them is all real numbers. So what I am going to leave up to you is to finish this graph right here and then use the information we just did to try to answer the questions in the problem set for problem set lesson 18, 1 through 10. Have a great weekend.